Good afternoon, students. Am I audible to you? My voice is coming. Just say yes.
Yes, ma'am.
Okay. Okay. Good afternoon to all of you. Now see, after your semester exam, terminal exam, now we are going to start our preparation for the coming unit test 2 exam. So for that, states of matter chapter is there. So we are going to study. Now in this year for 11th standard, you are basically going to study about the gaseous state. Liquid state is also there, but due to the reduced syllabus, few part of the liquid state it is omitted, it is reduced over in the textbook. Now we are going to study gaseous state. Basically, students, we are aware of 3 states of matter. You know, solid state, liquid state, and gaseous state. So why there is a difference between these 3 states? What does makes these 3 states different? If we will say solid, we see the molecules in solid state, they are very closely placed. They are very tightly placed. But when we go towards the liquid state, means when we will heat solid, solid will turn into the liquid. So solid is turning into the liquid. In this liquid, the molecules are what? They are little away from each other, and that's why liquid don't have a shape. Because the molecules in liquid, they are not compactly placed. And liquids, that's why they are flow. Liquid molecules, if you will pour liquid on the surface, it doesn't stay at one place, it just go on moving. So it shows that molecules are not closely placed, or it means that when we heat solid, the molecules present in the solid, the bond present between the 2 atoms in the solid, they move away from each other due to the provision of the heat. The bonds between the molecules is getting weaker, and the distance between the bonds between the 2 atoms is increasing. Now, after liquid state, further if you heat, what happens? Liquid molecule starts moving much more away from each other. So when you see water, and when you heat water, and what you observe, water is getting converted into the water vapor. So that is the gaseous state of the water. So why water means why there is a conversion from liquid to gas? Because when we heat liquid, the bond between the molecules become more weakened, and due to this increase in the distance between the molecules are moving much away from each other compared to liquid. So that's why in gaseous, molecules are randomly moving. Now this is because of this is because of the intermolecular bonding. So we are going to study, first of all, what are the different intermolecular forces are there. So these intermolecular forces are responsible for any of the state. If it is solid state, intermolecular forces between them are very strong. Now, intermolecular forces are 2 types: attractive forces as well as repulsive forces. Means when we say intermolecular forces, it's not only the attractive forces, but at the same time it is a repulsive forces are there, because there may be a repulsion between the like molecules, and there is an attraction between unlike molecule. For example, let's take hydrogen and chlorine. So there will be attraction between hydrogen and chlorine. Why? Because hydrogen is a positively charged atom, whereas a chlorine is a negatively charged atom. So electronegativity of chlorine is more. Why of chlorine is more? Because in chlorine, more number of electrons are present. So due to the more electron, it is more electronegative, and due to the more electronegativity, chlorine, what chlorine will do? It will hold hydrogen with itself. So one is less electronegative and other one is more electronegative. So it is called as the attractive forces. But what are the repulsive forces? Repulsion means moving away. When the molecules of a same type, suppose hydrogen atom and hydrogen atom, it will place hydrogen atom together. So what will happen? These 2 molecules having the same charge, that's why they won't form a strong bond with each other. So kind of bond will form, that will be a covalent bond by sharing of electron. but the force of attraction as such, there is a not there. Now, so unlike like molecule repel each other and unlike molecule attract each other, and on this basis, repulsive and attractive forces plays a very important role. Now, attractive forces are decreases with increase in the distance. Yes, suppose a solid molecule, if I'll hit solid molecule, what will happen? The molecules present in the solid will start moving away from each other due to providing the heat. So what is going to increase then? Distance will increase. So if attractive forces are decreases, what will happen? Distance will increase. Attractive forces decreases means what? Molecules are not coming closer, but they are moving away. As they are moving away, means intermolecular distance between them will increase. Same way, if intermolecular forces are strong in solid, they will be less in liquid, and they are very, very less in gases. So gas, you see, gas molecules are always in moving. Now, there are the few physical properties which depends upon these intermolecular forces of attraction. Now, what are the physical properties we have studied? We have seen melting point, we have seen boiling point, vapor pressure of a substance, of a liquid, viscosity of a liquid, then the rate of evaporation, surface tension. So all these are certain physical properties of matter, and this can be well studied. So if you want to study a melting point, if you want to study the boiling point, what you should know? You should know the strength of attractive forces between the molecule. For example, let's take a melting point example. Suppose melting point of a substance A is 60 degree and melting point of substance B is 150 degree. So what does it indicate? Which substance is stronger? Substance A is stronger or substance B is stronger? Yes, anyone can answer me? If there are two substances, one have boiling point, melting point 60 degree, other has 150 degree. So which substance has a strong intermolecular forces, A or B? Yes, I don't want to take name of anyone. So those who are listening can answer. What do you think?
Ma'am, B.
Ha, correct. B is correct. So why do you think B is more?
Ma'am, because it has boiling point is very less, it's 60 degree.
So no, B has a 150 degree, I said. B boiling point is 150 degree and A boiling point is 60 degree. So correct answer is B. In B, intermolecular forces are strong. Why B intermolecular forces are strong? Because we have to provide more temperature to break the bond. So when we want to provide a more temperature means higher melting point. So 150 degrees higher. So the bond present between these molecules, they are so strong that we have to provide it more temperature. So one who has a higher melting point will contains strong intermolecular forces, and one which has a lower melting point will have a lower intermolecular forces. Lower intermolecular forces means by giving less amount of heat also that bond get easily break. Understood? So melting is what? Solid to liquid conversion. Now just I have given an example of melting. So like that, other physical properties are also depends upon the intermolecular forces. Now, students, we are going to study different types of intermolecular forces. This is very important. Actually, this is a basic of your further studies. Now, there are 5 intermolecular forces, types of intermolecular forces we are going to study. First is dipole-dipole interaction. Second is ion-dipole interaction, as you can see on the screen. Then dipole-induced dipole interaction. Fourth is London dispersion force, and last, which is very important, last but not the least, hydrogen bonding. So all 5 we are going to study one by one, and there is a difference between each intermolecular forces. There is a difference between all these interactions, so you have to understand them properly, and you are not going to get mixed up with different intermolecular forces. So now let's start with the first, dipole-dipole interaction. So dipole-dipole, this word, what does it mean? That first we will understand. Students, you might have heard about pole. Have you heard pole? Have you heard polar molecules? Or if you have not heard, I'll explain you. See, pole, when we say pole, Pole means what? Two poles. Positive pole and negative pole. You know, in the battery, it has a two poles, positive and negative. And accordingly, we put cell of a battery in the particular electrical appliances by looking at the positive and negative end. Same way, pole means what? Two end, one plus and one minus. So dipole, dipole. Di means two. So there is an interaction between the two poles. Interaction between the two poles means what? One pole has a plus minus charge, other pole also has a plus minus charge. So between plus minus charge, there will be interaction. So dipole, dipole interaction. Okay. So polar molecules experience dipole-dipole forces due to the electrostatic interaction between the dipole or on the neighboring molecule. Now, just now I explain you pole. Pole means positive and negative. So polar molecule, what does it mean? Polar means a molecule or polar covalent molecules are the molecules which have two charges, plus and minus. So which molecule have a plus minus charges? Polar covalent molecule, they have plus minus charges. What does it mean plus minus charges? So I'll show you one example. See on the screen, you can see HCl. This is a HCl molecule. So HCl molecule is formed by sharing electron between hydrogen and chlorine. Hydrogen has a 1 atomic number, chlorine has a 17 atomic number. Hydrogen, in its valence shell, only one electron is present. Chlorine, in its valence shell, number of electrons present are how many? 7. Because its final electronic configuration is what? What is it? 3s2, 3p5. So S2 and 3p5. So there are in third shell, there are 7 electrons. So chlorine, its octet is not completed. So as its octet is not completed, it will take 1 electron from hydrogen. And hydrogen has only 1 electron, hydrogen duplet. Hydrogen, it is not possible for hydrogen to complete its octet because hydrogen has only 1 electron. So instead of completing octet, it will try to complete its duplet. Duplet means 2 electrons. So hydrogen will take 1 electron from chlorine and chlorine will take 1 electron from hydrogen. So like that 1 electron gets shared between these two. So due to the sharing of electron, the type of bond will form is a covalent bond, or it is called as a polar covalent bond. Because as hydrogen will give its 1 electron, hydrogen will have a delta plus charge. You can see here delta plus charge, and chlorine will accept that electron. Chlorine will have a delta minus charge. So due to this polar nature, one will have a positive charge, other will have a minus charge. Why the two different charges are there? Because chlorine will have a more electron than the hydrogen. So due to the difference in the electronegativity, chlorine will have a delta negative charge and hydrogen will have a delta positive charge. So such molecules which has a two poles are called as a polar molecules. So you can see other example also where you can see polar molecule like HF, hydrofluoric acid. So bond between hydrogen and fluorine. Hydrogen atomic number 1, fluorine atomic number 9. So fluorine will also require how many electron fluorine require? 2,7. So 1 electron fluorine will require to complete the octet. So like that, fluorine will have a negative charge, hydrogen will have a positive charge. Same way you can see other example of the polar molecule, iodine and chlorine. So iodine and chlorine, between these two molecules, iodine has a positive charge and chlorine have a negative charge. So such polar molecule, when they undergo interaction, it is called as a dipole-dipole interaction. Now, just now we have seen of the HCl molecule. So one end of a molecule has a partial positive charge. So this one end of the molecule have this one pole of a molecule have a partial positive charge, and other pole of the molecule have a partial negative charge. So due to this partial positive and negative charges, as a result of this, polarization of the molecule takes place. The molecule possesses a dipole moment. You know, polar molecule, they have a dipole moment. So what does this dipole moment? Dipole moment is a product of magnitude of charge and distance between the center of the positive and negative charge. So due to this polar nature, polar molecule possess dipole moment. Dipole moment is a formula is what? It is a product of the charge and divided by the distance between the two charges. So, or two centers. Now, one is positive center and chlorine is a negative center. So, between this, how much is the charge? How much is the distance? That distance, we are going to divide it to the magnitude of the charge. So, it is called as dipole moment. So, dipole moment in the Greek, it is measured in the alphabet. Symbol is given as a mu. Okay, and it is also, its unit is capital D. It's called as a debye. Debye is the person who has done work on the dipole moment, and that's why its unit is named as a D. And in the Greek letter, it is mentioned as a mu. So dipole moment is a vector quantity. Why it is a vector quantity? Because it has a direction. Because what we can say, polarity of molecule is moving from positive to negative. We know negative, the atom will have a more electronegativity. That's why its polarizability is moving from positive to negative, and that's why it is a vector quantity. We have showed with the arrow. The tail of the arrow is towards the positive center, and the arrow of that what we can say, dipole moment is towards the negative. Okay, pointing towards the negative. Now, see another example, as I have said, HF, hydrofluoric acid. So in HF also you can see how arrow is showed. It is moving towards the fluorine. Why? Fluorine has a more electronegativity and hydrogen have a more positivity. The Lewis structure represented as an electron density shift. Now Lewis structure means what? We can show the number of electrons present in the valence shell, and we can show how electrons are moving. Does the polar molecule have a what? Permanent dipole moment. So keep this in mind. This may come in MCQs. What does it say? Polar molecule have a permanent dipole moment. Why permanent dipole moment? Due to the presence of positive and negative charges, they have a dipole moment, and that dipole moment is remain fixed because pole will not, polarity which generated on the molecule is permanent, and that's why dipole moment is also permanent. When the polar molecule encounters another polar molecule, suppose in the vicinity of HCl, if I'll keep another HCl molecule, okay. So if the polar molecule is encounters another polar molecule, the positive end of one molecule will of the polar molecule will attract towards the negative end of the polar molecule. And many such molecules have a dipoles, and their interactions are called as the dipole-dipole interactions. So dipole-dipole interaction means what? See, this one dipole, positive, negative. If I'll place one more molecule of HCl beside this HCl molecule, so you tell me which atom among the hydrogen and chlorine will come in vicinity with this chlorine atom? This chlorine has a negative charge. So what do you think? Which atom among the hydrogen and chlorine of the another molecule of HCl will come in vicinity of first HCl molecule? Yes, answer me. So I'll come to know whether you have understood or not. If I'll place another HCl molecule, okay. So if I'll place another HCl molecule, how you will place? You will place Cl first or hydrogen first? Yes. Do you know this? See, if I want to place another HCl molecule, here is chlorine is present, correct? Chlorine is what? It is a negative. So beside negative, which molecule will be there? Positive. So I'll write again H and Cl. So I will place hydrogen beside the chlorine, and then again I'll write chlorine after the hydrogen. So it is HCl, HCl. Now next molecule, if I want to place like third molecule, that will be also HCl. Means we have to follow positive, negative, positive, negative. So beside chlorine, I will place hydrogen, and after hydrogen, chlorine will come. Again beside chlorine, I will place hydrogen. So alignment of the molecule is how? Positive, negative, positive, negative. That is, positive and negative will come closer. Now the energy of the which is required for this. So the forces are generally weak. These forces are very weak forces. So with the energy of order of 3 to 4 kilojoule mole inverse. So the energy which is required is 3 to 4 kilojoule mole inverse. So these are not so strong forces, but they have certain bond energy. It is 3 to 4 kilojoule mole inverse. Now other example like butyl chloride, dimethyl ether, iodine and chlorine. So iodine chlorine interaction is showed here. Iodine and chlorine. Iodine has a positive charge, chlorine have a negative charge. Okay, now beside this chlorine again what will come? Iodine and chlorine. Iodine and chlorine. So positive, negative that way. Now butyl chloride is also a polar molecule. Dimethyl ether is also a polar molecule. So these are example of the polar molecule. Now, if you see here, there is one table is given in which polar molecules are mentioned. So this is a formula of alkane. You have not yet studied alkane. So I'll just show you. Alkane is what? It is a alkane is a family of a hydrocarbon which contains molecular formula CnH2n plus 2. So methane is the first member, ethane is the second member, and this is a propane. Propane having the 3 carbon atom and how many hydrogen atom? 8 hydrogen atom. So it is a straight chain molecule. Here you can see between the 2 methyl group, between the 2 carbon atom, one oxygen is there. This functional group is called as a ether. And here it is a chlorine is attached to the carbon atom. So it is alkyl chloride. Here cyanide group is attached to the methyl group. Now, if we'll compare this all substances, here positive negative charges cannot be developed. Why cannot be developed? Polar charges cannot be developed because everywhere the kind of molecule is same. Carbon, carbon and carbon, hydrogen and hydrogen. That's why they are non-polar. These are non-polar. For polarity, one should be more electronegative, one should be one electropositive. Now this one is polar. Why? Because oxygen is electronegative and methyl group is electropositive. So it has a polarity, and that's why its polarity is 1.3. So as it has a polarity, you can see its boiling point is increased to 248. It has a very less dipole moment. That's why its boiling point is less than 248. It is 231. Manje, what does it indicates that? As the dipole moment is increases, boiling point is increases. As the dipole moment is increases, boiling point is increases. No matter how much its molar mass. Molar mass, suppose this is methyl chloromethane, its molar mass is 50.49. Its boiling point is 249. So it is little higher. But if you see next member, cyano group attached to the methyl group, its molar mass is very less. Lesser than all three. It is 41.05. Still, it has a higher boiling point. Why higher boiling point? Because the kind of atom which are present, that is carbon and nitrogen, cyano group, and it is highly electronegative group. So as electronegativity is very high, the kind of bond is very strong. If bond is strong, boiling point will be high. Understood? So on this way, on the intermolecular forces, your melting and boiling point of the substance increases. So dipole moment, with increase in the dipole moment, boiling point is increases. Keep this in mind. And how dipole moment is increases? By increasing the electronegativity. If more polar molecule, more is the dipole moment, more is the boiling point. So I think you have understood dipole-dipole interaction. So dipole-dipole interaction is the interaction present between the two oppositely charged molecule with having a permanent dipole moment. One has a positive charge, partial positive charge, one will have a partial negative charge. And when we will place other molecule of a same type, so they will align themselves in a such way that negative end will come with the positive end and positive end will come with the negative end. After that, we will see ion dipole interaction. Now see student, earlier we have studied dipole-dipole interaction. We have studied dipole-dipole. What is difference here? Ion is dipole is removed and ion word is there. So ion dipole. So see, sometimes this heading also helps you to understand what kind of interaction it is. Ion, what does it mean? Ion means cation or anion. Cation means positively charged. If you can able to see in diagram, you can see here Na plus. Na plus means what? Sodium with the positive charge. It's called as a cation. So it is an interaction between one ion and other dipole molecule. One ion and other polar molecule. Now, if you will you just see the diagram. I am going to explain what is this ion dipole interaction, but just see the diagram. See in diagram, you can able to see sodium atom is present in the middle, and that sodium has a positively charge. So it is a sodium cation, and sodium cation to which what is attached over here? Water molecule. Water molecule means what? Two hydrogen and one oxygen. So two hydrogen atom are attached to one oxygen atom, and this is our water molecule. So in water molecule, you know, what do you know in water molecule? Formula of water molecule is what? H2O. So among H2O, oxygen has a more number of electron. It has a 8 electron. That's why it is a more electronegative, whereas the hydrogen has a less electron. That's why it is more electropositive. And that's why, see, on oxygen, which charge is showed? You can see in the book also. In book, if you have book with you, on page number 137, it is showed that on oxygen, charge is negative. That is delta minus partial negative charge. And on hydrogen, delta positive charge is there. So between sodium atom and oxygen atom, if you will see how many oxygens are there, this orange color, all are oxygen. So if you will count 1, 2, 3, 4, 5, 6. So 6 oxygen atoms are attached, they are in dipole-dipole interaction, ion dipole interaction with sodium ion. So there is an ion dipole interaction between the 6 hydrogen atom and 1 sodium atom. Now it depends upon the number of sodium atom. It's with how many atom it is going to form an interaction. It depends upon its atomicity, we can say. Now, an ion dipole force is a result of electrostatic interaction between ion. That ion may be cation or that ion may be anion. So, ion dipole interaction is the interaction between ion and a polar molecule. It is an interaction, electrostatic interaction between a ion and a partial charge or a polar molecule. So now you are aware of polar molecule. So what are polar molecule? The molecule which has plus or minus charge. So which molecule have plus or minus charge? Hcl molecule have a plus minus charge. HF molecule have a plus minus charge. Like that, water molecule also have a plus minus charge. So positively charged cation, ion, is in interaction with polar molecule. So ion dipole interaction is an interaction between ion and the dipole, ion and a polar molecule. So keep it in mind. It is very easy. So in an exam, if question come, explain ion dipole interaction. So what you have to write? An ion dipole force is an interaction, or is a result of electrostatic interaction between ion. In bracket, you have to write it may be a cation or it may be an anion. So between cation and anion with polar molecule. So the strength of interaction, the interaction which takes place. Interaction means what, student? Interaction means the type of bond which forms. So the bond which forms between the sodium, see down it is written, a sodium ion, which is a cation, with the water molecule. So the bond which forms between the polar molecule, water, and the positively charged sodium cation depends upon the charge and size of an ion. So strength of interaction depends on the charge and the size. So this is very important note about the ion dipole interaction. So ion dipole interaction is strength is depend upon the charge and the size of ion, as well as it also depends upon the magnitude of dipole moment and size of the molecule. So it is also depend upon the dipole moment and the size of molecule. So these three things you have to keep in mind, that ion dipole interaction, first it depends upon size of the ion and the charge of the ion, as well as it depends upon magnitude of dipole moment and size of molecule. Now, ion dipole forces are particularly important in aqueous solution. So see students, basically ion dipole interaction you will able to see in the aqueous. Aqueous means what? When we will dissolve in water. So as you can see, sodium atom is in interaction with water molecule. Means what? When I'll put sodium chloride in the water, means your table salt, which is you eat at home, that's sodium chloride table salt. If I'll put it in water, what you observe? It got dissolved, it get disappear. But what kind of chemical interaction takes place between the sodium atom, water molecule, or chlorine ion and the water molecule? So this interaction takes place. This sodium ion Na plus and chloride ion Cl minus, they get separate from each other. Sodium goes with the water molecule, chlorine will also goes with the water molecule. And this process is called as a hydration. See, I'm going to read it. When an ionic compound, sodium chloride, is dissolved in water, ions get separated and surrounded by the water molecule, which is called as a hydration of sodium ion. Very important. So when we dissolve salt into the water, when we want to make a salt solution, what happens? Positive and negative ions, they get away from each other. Like sodium get converted into the Na plus and chlorine get converted into the Cl minus. Now sodium will come in association with water molecule and chlorine will also come in association with water molecule. So this process is called as a hydration. So understood, hydration of sodium ions means what? Now student, very important thing. See, sodium has a plus charge, that's why it is in a vicinity with negatively charged oxygen atom, correct? So see, sodium is in contact with the oxygen atom and there are 6 oxygen atoms. Now, chlorine has a minor charge. So chlorine has a minor charge. So chlorine won't come in association with oxygen. Minus won't form any interaction. So then chlorine will come with which atom in the water molecule? Please answer me if you have understood. Chlorine has a minor charge, so chlorine won't come with the negative. Negative won't come to close to each other. So chlorine will form an interaction with which ion in the water molecule or which atom? Yes, answer me. Thakur Kushi, yes, have you understood? You people are just keep the your mobile on and you are not listening. Are you understanding?
Ma'am, sodium.
What I have asked that, see, sodium is coming in contact with oxygen atom which is negatively charged, correct? No? In ion dipole interaction.
Chlorine. Chlorine.
So chlorine molecule, chlorine ion, negatively charged chlorine ion will come in contact or interaction with which part of the water molecule? Yes.
NaCl.
I am clearly asking, if sodium is coming in contact with negatively charged oxygen atom of water molecule, then Cl minus ions will come in contact with which part of the water molecule? Which ion of the water molecule?
Ma'am, hydrogen.
Hydrogen. Yes, I am asking in 3 or 4 different ways. Yes, Cl minus ion, correct it is. Cl minus ions will come in interaction with H plus ions. Why? Because chloride have a negative charge. That's why it will come in contact with hydrogen ions. It won't come in contact with oxygen ions. Understood? So this is what is ion dipole interaction. Okay, now cation are smaller in size than the isoelectronic anion. You know cation. Cations, what are cations? Positively charged molecule. And how cations form? By giving the electron. So when atom lose its electron, cation forms. So electron losing means decrease in the size. Suppose sodium has a 11 atomic number. Sodium, in order to form sodium plus charge cation, sodium will release 1 electron, correct? So it will form Na plus ions. So Na plus ions will have a smaller charge compared to Na atom. That's why cations are smaller in size than the isoelectronic anions. The charge density on, see, anions. In anions, what happens? In anions, electrons are accepted. If electron will accept, size of the orbital will increase and the size of that particular anion will also increase. the charge density on cation like Na plus is more concentrated than anion. This makes an interaction between Na and negative end of the polar molecule water, whereas negative end of the water molecule will interact with the Cl minus ions. Negative end of the water molecule interaction is with the Na plus ions, and whereas stronger than the corresponding interaction between Cl and the positive end of the water molecule. So what I want to tell you, there are two types of interaction. One interaction between water molecule and sodium ion, other interaction between water molecule and Cl minus ion. So this interaction will be what stronger than the corresponding interaction between the Cl and the positive end. So cation and negatively charged molecule forms a stronger interaction compared to the negatively charged anion and the water molecule. More the charge on the cation, stronger is the ion dipole interaction. Keep it in mind, students. So if the charge on cation, like positive charge is more, interaction will become more. So suppose there are the two ions. One is magnesium ion, which has a +2 charge. Other is a sodium ion, which has a plus charge. So which will form stronger interaction, magnesium or sodium? What I have said, which has a more positive charge will have a stronger interaction. So magnesium has a more positive charge. It has a 2 plus positive charge, whereas sodium has only 1 plus charge. So magnesium will form a stronger interaction compared to sodium. And suppose if I bring in picture aluminum also. So aluminum will have a 3 plus positive charge. So aluminum will have a much stronger interaction as compared to the magnesium. So you can see in the book, there is a comparison between sodium, magnesium and aluminum is given, where aluminum is a stronger in interaction compared to magnesium than sodium. Okay. So have you understood ion dipole interaction? This name itself tells us it is an interaction between ion, it may be cation, it may be anion with the dipole. Dipole is a polar molecule which has a positive and negative end or charges on it. Dipole-induced dipole interaction. Now see, this is a third interaction. Here, dipole-induced dipole. Dipole, you are aware. What is it? A molecule which has a 2 end, plus or minus. Induced dipole. Induced means what? You know what? Induced means purposely we are creating or we are applying other molecule to generate a dipole moment or to generate a positive negative charge or to generate a polarity. So for a short while, we are making non-polar molecule polar. So when we will see example, you will understand. So dipole-induced dipole, it means that with the help of polar molecule, we will make non-polar molecule to become a polar. Now, when a polar molecule, for example, water, you know in water, plus minus charges are there. Ammonia also has plus minus charges, but non-polar molecules. So what are the example of non-polar molecule? Let's take benzene. Why benzene is a non-polar? Because if you see the molecular formula of benzene, it is C6H6. So there is an equal distribution of electron between the 6 carbon and 6 hydrogen. There is a double bond present, alternate double bond in benzene. So due to which electron cloud is getting equally distributed, and that's why there is a strong polarity is not there. One carbon is more positive, hydrogen is negative, or hydrogen is negative, carbon is positive. It doesn't happen because equally electron density is getting shared. That's why benzene is a non-polar. Benzene will never have a polarity. But we can make benzene polar. How you will make a benzene polar? By bringing this benzene in vicinity with the polar molecule. So when we will bring polar molecule in contact with non-polar molecule for a short or for a while or for a temporary, we can make non-polar molecule polar. So down you can see here in the this interaction which is given between the polar and non-polar molecules. See, non-polar molecule is benzene, C6H6. Polar molecule is ammonia. See, ammonia is what? Nitrogen with the 3 hydrogen. Nitrogen is with the lone pair of electron. This lone pair of electron means it has a in its inner shell 2 electrons, and outer shell it has a how many electrons? 5 electrons. Okay, so 5 electrons. Among the 5 electrons, 3 hydrogen shared one electron, and remaining 2 electrons are what? They are a lone pair on nitrogen. That's why nitrogen is more electronegative and hydrogens are electropositive. So that's why it is a polar molecule. Benzene, as I've said, it doesn't create any polarity. But if I'll bring this non-polar molecule benzene in vicinity with the polar molecule, slowly there is a generation of non-polar molecule. There is a induction or there is a formation or creation of a polarity in non-polar molecule. So you can see now carbon is little delta positive and hydrogen is delta negative. So carbon which was and hydrogen which was not polar at all, due to the presence of polar molecule in vicinity for a short period or for temporary, carbon showed positive charge, hydrogen showed negative charge. So ammonia is a polar, has a permanent dipole moment, while benzene is a non-polar, has zero dipole moment. The force of attraction, what is happened between these two? Force of attraction. This nitrogen has a lone pair of electron, it creates a force of attraction on carbon. As nitrogen creates a force of attraction between the carbon, nitrogen become negative. As it is negative only, and carbon become positive. This bond, this temporary bond form, and due to this temporary bond, carbon is positive now and hydrogen is again negative now. So as I was telling you that the force of attraction developed between the polar and non-polar molecule is a type of dipole-induced dipole interaction, and it can be seen in the following. So it is showed here. This way we have to represent. So in exam question will come, explain for 2 marks or write a short note on dipole-induced dipole interaction. So there you have to explain that a dipole-induced dipole interaction is a interaction between a polar molecule, for example, ammonia, water, and between the non-polar molecule, for example, benzene. So polar molecule has a permanent dipole moment, whereas non-polar molecule has a zero dipole moment. When polar molecule come in vicinity with non-polar molecule, due to the force of attraction, there is a generation of charges or induced dipole moment developed on the benzene, and benzene shows for a temporary dipole moment. The polar it becomes polar for a temporary, and such kind of a dipole moment which induced due to the presence of polar molecule is called as a dipole-induced dipole interaction. So have you understood, students? Yes?
Yes, ma'am.
Okay, fine. Now this is again a very important and very what we can say, a very different kind of a dispersion forces these are. So we will understand it slowly. We will go. See, London dispersion forces. London is maybe the name of scientist who has seen Fritz London in 1930. He is a German physicist. He has proposed this London forces. And what he has studied that we are going to see. So London dispersion forces is what? It's a study of intermolecular forces present among the non-polar molecule or individual atom of a noble gas is very interesting. So see, student, here not at all polar molecule is involved. We have seen in 3 interaction where polar molecule was there. In dipole-dipole also polar molecule is there. In ion dipole, cation, anion, and any of the polar molecule. And in dipole-induced dipole, polar molecule and non-polar molecule. But in London dispersion forces, it is totally non-polar molecule or a noble gas. Noble gas means which gases? Inert gases. Neon, helium, xenon, radon, krypton, and so on. So, if you want to create a polarity between a non-polar molecule or a noble gases, let's see, it is very interesting. Now, what we have studied that benzene does not have a dipole moment. Its dipole moment is totally zero. So there is a no dipole-dipole forces exist between the benzene. Now, in case of a non-polar molecule or in inert gases, what does it exist? Dispersion forces exist. Okay, what does it exist between the non-polar molecule and the inert gases? Dispersion forces exist. Now, what are these dispersion forces? They are also called as the London forces. And they are actually momentary dipole. Momentarily dipole means what? Momentary means for a while. Momentary means for a short period of a time, there is a generation of a dipole. So they are called as a momentary. So you will say, ma'am, in non-polar molecule, they don't have a polarity. Then why for a short period of a time, or why for a momentary also there is a dipole is exist? Yes, dipole do exist for a short period. So we'll see how for a short period dipole do exist. You have heard about the forces that are van der Waals forces. So these are the weakest of the interaction. Van der Waals forces are weakest forces, and these are surface forces basically. So it is a weakest intermolecular forces that develops due to the interaction between the non-polar molecule. So van der Waals forces are the forces which are the weakest intermolecular forces developed due to the interaction between the two non-polar molecules. So all atom or molecule experiences London dispersion forces, which is a result of motion of electron. Now see students, you know, a molecule has an atom have an electron, center there is a nucleus, and around it there are electrons are present. And what do you know? Electrons are moving around a positively charged nucleus. So London dispersion forces, which results from a motion of electron. So when electron move, when move, a negative charge is moving around the positive charge, around the positive nucleus. Due to the movement of a, when the negative charge moves, how it moves? In a circular way. So one time it is at one place, when it is moving, it is another place, then it is another place. Due to there is an imbalance in the positive negative takes place, and due to which a momentary, what creates? A dispersion forces creates. So this momentary dipole on one atom can affect the electron distribution in the neighboring atom and induces momentary dipole in them. As a result of weak attractive forces develop. So how this dispersion forces develops? You bring in front of your eyes atom in the center, nucleus, around the nucleus electrons are moving. When electron moves, they move circularly, okay, and while moving around the nucleus, for a temporary they generate, or for a momentary they develop a dipole, plus minus charge, they forms a dipole for a momentary. And this momentary dipole on one atom can affect the electron distribution in the neighboring atom and induce momentary dipole in them. So for a short period of while, there is a momentarily dipole formed in them. So due to result of weak attractive force develops. Now for example, let's see substance where the dipole London forces do exist. So oxygen, carbon dioxide, nitrogen, halogen, methane gas, helium, and other noble gases shows van der Waals forces of attraction. And the strength of London forces increases with increase in the molecular size. So see how London forces are increases. If the size of molecule will increase, the London force will increase, means they have the little stronger dispersion forces or polarizability in them. So molecular mass and number of electron present in an, it depends upon the three things: molecular size, molecular mass, and the number of electron present in the atom or molecule. So have you understood? Oxygen. So between the two oxygen atom, if bond is there, so what type of a interaction generate between them? Dispersion forces or London forces. Why? Because oxygen is a non-polar molecule. In carbon dioxide, between carbon and oxygen, electronegativity difference is very less. So that's why there also you will see formation of a dispersion forces, even nitrogen, halogen, methane gas, and so on. The strength of London forces increases with the molecular size, number of electron and a mass of a molecule. When two nonpolar molecules approaches each other, attractive and repulsive forces between their electron and nuclei will lead to distortion in the size of electron cloud and the property referred to as a polarizability. Now just imagine in front of your eyes, if two different molecules are approaching towards each other for an formation of a bond or for an interaction. Okay, so one molecule may have a different attractive forces, other molecule may have a different attractive forces. Due to the different attractive forces between these two, or the number of electrons which are present between them, there is a distortion in the size of electron cloud will there, and this property is called as a polarizability. Polarizability is a measure of how easily an electron cloud of an atom is distorted by the applied electric field. So if I'll apply an electric field and between them, if we will place this molecule, so this electric field will get affect polarizability is what it is a measure of how easily electron cloud of an atom distorted. So if I'll apply an electric field and in between if I'll keep a molecule, so due to the applied electric field, the cloud of that particular atom will get distorted, will get shift. The ability to form a momentary dipole, that means the ability of another molecule to become a polar by redistributing its electron, is known as the polarizability of an atom or a molecule. So basically, there are three things we have studied in London forces. First, we have studied van der Waals force of attraction. Then we have studied, first of all, we have seen London dispersion forces are present between the molecule which are non-polar or which are inert gases, noble gases, or a molecule of same kind like oxygen, nitrogen, helium, and so on. So what does make them polarizable for a while? A London force. So what is London force? London force is a kind of a what we can say, momentary dipole which generates due to the movement of electron around a nucleus. So movement of electron cloud around a nucleus, there is a generation of a momentarily dipole. These forces are also called as the van der Waals forces. And van der Waals forces are what? They are the weakest forces which are present between the non-polar molecule. As well as we have seen that when two non-polar molecule approaches to each other, there is a generation due to the difference in electronegativity, there is a generation of momentary dipole takes place. Okay, student. Now I think another lecture is there. So I'm ending this. So example of this we will study on Saturday. Again, I will revise this topic and we will start the next part of this chapter. I'm going to end the lecture. You read, study. You have any doubt, you ask me. Maybe in online, it may be going little fast.